Hi everyone, today I'll be solving the two-sum lead code problem. So first, let's read the question. Given an array of integer, the array is called nums, and an integer target, we want to return the indices of the two numbers that add up to the target. And we can assume that each input has exactly one solution, and we can't use the same element twice, and we can return the answer in any order. So for example, in this scenario, nums is this array 2, 7, 11, 15, and target is 9. Now we see that 2 and 7, they add up to 9, and so we would return 0 and 1 in any order, because those are the indices of the two numbers that add up to 9. In this example, we see that nums is this array, 3, 2, 4, and target is 6. So we see that 2 and 4 add up to 6, and the index of 2 is 1, and the index of 4 is 2. So we will return like 1, 2, or 2, 1. Again, the order doesn't matter. And here, our nums array is 3, 3, and our target is 6. So 3 plus 3 equals 6, so we will return like 0, 1, or 1, 0. And here, we have a couple of constraints. So num star length is at least 2. So we don't have to worry about like if the array is empty or if there's only one number. And these are like the range from like what each element can be and what the target can be. And again, only one valid answer exists. And here it says in the follow-up, can you come up with an algorithm that is less than O of n squared time complexity? So I'm going to first talk about the O of n squared time algorithm. I won't code it out, and then I'll explain the O of n time complexity algorithm. So let me go here. So let's use this example, 2, 7, 11, 15. So this is our nums array. So nums 2, 7, 11, 15. And our target, I'll just denote as t, is 9. So this is the O of n squared approach. So what we can do is we can have a nested for loop or double for loop. And in the outer for loop, we loop through each of the elements. And in the inner for loop, we will loop through every element to the right of the current element. So for example, let's say that right now we start at 2, right? So in our outer for loop, we will have to, in our inner for loop, we will like loop through 7, loop through 11, loop through 15. And if any of these, if any pair adds up to the target 9, then we stop and return the two indices. So in this case, we see that 2 and 7, they add up to 9. So we will return 0 and 1 or in any order. But let's see that now. Suppose that the array was like changed, like the elements were in different order. So let me erase this, and let me erase this. So the same numbers different order. So suppose now we have 11, 15. Let me erase that and do it. Oops. 15, 2, and 7. So the same numbers, just in a different order. So again, right, for the O of n squared solution, how we can do it is we start from 11, and we will look at all the elements to its right. Now the reason why we don't look at any elements that came before it is because we would have gone to those elements and we would have seen that there's no possible combination that add up to the target. So in the outer for loop, we first go through 11, right? In the inner for loop, we go through 15. Does 11 plus 15 add up to 9? No, it doesn't. We keep going. We now go to Does 11 plus 2 add up to 9? No, it doesn't. We keep going. We have 7. Does 11 plus 7 go to 9? No, it doesn't. So in our default, we now go to 15. And again, right, the reason why we don't check any previous numbers is we already gone through that pair before. Here, right, we went through 11 plus 15, and we know that doesn't add up to 9 with the target number. So 15. The first element after 15 is 2. Does 15 plus 2 add up to 9? No, it doesn't. Let's go to 7. Does 15 plus 7 add up to 9? It doesn't. So again, in the outer loop, we go to the next number in the array, which is 2. And now this time we go to the first element that's after 2, which is 7. And does 2 plus 7 add up to 9? It does. So we will return 2 and 3, or 3 and 2. So that's the n squared approach. Basically, you have a double for loop, and in the outer for loop, you go through each of the numbers or each of the elements in the nums array, and in the inner for loop, what you do is you go through each of the elements that's after your current element in the nums array, and you just keep repeating this, like you just keep going through the elements in the nums array until you reach the pair that adds up to the target number. So that's the O of n squared approach. Let me go to the O of n approach. So again, let me draw out the array. So we have 2, 7, 11, 15. And the target key is 9. So we're gonna do something similar here, but we're gonna. So how we're gonna do this? How we're gonna do this in O of n is that we're gonna loop through the nums array, and each time we loop through, so each element we hit, we check to see that if the difference is stored. So the difference between the target and that number. If it's not, we add that value to a hash map. The key will be the number itself, and the value will be the index. So for example, it means this. So let's say we have a hash map called cnums. What we're gonna do is, like I said before, we're gonna loop through the nums array. This time only once. And for each element that we encounter, we're gonna take the difference between target and the number. And if the difference is inside cnums, then we can just return like the current index and the value of the values where the key is the difference. If we don't see the difference inside the cnums, what we're gonna do is we're gonna add the current number into cnums as the key, and its value will be its index. So for example, let's do a quick like a run through. So we start with 2, right? So 9 minus 2 equals to 7. This is our difference. So we see that. So we don't check if this difference 7 is inside cnum. It's not, because cnum is empty. So what we're gonna do is we're gonna add a new entry into our cnums hash map. So the key, like I said, will be the element, the current element, and the value will be its index. So let's continue. So now we go to 7. So 9 minus 7 equals to 2. Again, this is the difference. Now we check the hash map, and we see that there is a 2 here. So we can easily get the value associated with this key, and we can keep track of the current index in the from a loop, right? And so we see that, okay, we can return 0, 1, or 0. So let me try let me do this again, but with the order changing. So again, same for numbers. Let's do 11, 15, 7, 2. So again, the target is 9, and cnums is empty hash map. So we start the 11. 9 minus 11 equals minus 2. That's a diff. We check if the diff is inside cnums. It's not because cnums is empty. So what we're going to do is we're going to add a new entry to cnums. So 11 will be the key, and its index, which is 0, will be the value. So now let's go to 15. So 9 minus 15 equals minus 6. Is our difference? Is minus 6 inside cnums? It's not. So we're going to add a new entry. So here, this is from previous. Now we have 15 as the key and 1 as the value. So now let's go to 7. 9 minus 7 equals to 2. Is our difference? We check if the difference is inside our cnums hash map. It's not. So we add it to cnums. We add 7 as the key and its index as the value. And finally, we get 2. 9 minus 2 equals to 7. We see that 7 is inside the cnums hash map. So we're gonna return 2, 3, or 3, 2. Again, the order doesn't matter as a result. So now let's code this up. So I'm going to be using Python, and so here, like I said before, I'm going to initialize. So I'm going to create a hash map. That is in Python called a dictionary called cnums, and this is where we're going to store all of the previously seen numbers. And so now what I'm going to do is I'm going to loop through each element of the array, and I'm going to call each element we had I'm going to set a variable to be called nums. And difference, like I said, is the target minus num, like the current element we see. If the difference is in cnums, then we return I and cnums difference. Because like I said, right, the key will be the element inside nums, and its corresponding value will be its index. So that's why we do see cnums diff. Otherwise, we just add a new entry, and like I said, the key will be this should be num. Yeah, so add a new entry inside cnums, and the key will be num, like the current element we're encountering, and the value will be its corresponding index. So let me run this. Let me do this first. Okay, let me run this. And you can see it works. And yeah, this is the O of n solution. And like I mentioned before, the O of n squared solution is just to have a nested for loop where you loop through each of the elements in the outer loop, and in the inner loop, you loop through all of the elements that's after the current one you're on, and you want to see if there's any two number pairs that add up to the target. If there is, you just return the indices. Yeah. That's all for this video.